Hello, this is Mitchell Prentice here, and today we are looking at the language used in algebra. So different words that are used when we're talking about expressions in algebra. So the first thing that we have to do is just write down some kind of algebraic expression so we can look at this language that's used. So for example, just say I have 3x minus 7y plus 8. Okay, this is called an algebraic expression. Okay, it's called an algebraic expression because we are using different letters, which I'll give them another word in a second, to represent some unknown number. Okay, it might be that x and y could represent, carrots and beetroot. It doesn't really matter what we've got. We just recognize that we're using these letters to represent unknown numbers. So the first thing that we just want to recognize is we don't call them letters. This x and y, they are called either variables or pronumerals. So we'll normally use the word pronumerals. So that is, they are in replacement for a numeral, for a number. Okay? Sometimes we call them variables because we know they could represent any number. So that means that they could vary. So we could have y is equal to 0 or 1 or 2 or 3.7. It wouldn't matter what it is, but sometimes we call them variables as well. Okay, so x is a variable or pronumeral, and y is a pronumeral or variable. Okay, the thing that's in front of the pronumerals is called the coefficient. Okay, we call them the coefficient. So we would say that 3 is the coefficient of x. The y term, though, we would actually keep that negative with the 7. So this is actually, this part here is actually, we would say, negative 7y. So, of course, you can interchange with minus 7y as well. That's fine. But we would say actually that the coefficient of y is negative 7 or minus 7. Okay, so negative 7 is the coefficient of y. Now, the other thing is that we recognize is I've just done a red circle around what we call a term. So this negative 7y is a term that we use in algebra. And there's actually in this expression 3 terms. There's negative 7y. We've also got a plus 3x term. And we also have, I'll put this back around it, we've also got a plus 8 term that we'll call a constant term in a second. Okay, so there's 3 terms here. And the reason why I've just got them in different colors is because it actually doesn't matter what order we put these 3 terms in, as long as the negative is staying with the 7. So we could actually write these 3 terms in any order. So for example, I could write negative 7y plus 8 plus 3x. They are still the same 3 terms. I've just put them in a different order, negative 7y, plus 8, and plus 3x. Okay? It's also really important, therefore, that when we are going through to work this out, we are not taking away the 8. A lot of students get confused and say it's negative 7y plus 8. We are not taking away 7y plus 8. We are only taking away 7y, and we are plussing 8. Okay, so it's a separate thing. If there was a brackets around, like we could end up looking at this and putting brackets brackets around soon, then it's take away 7y plus 8. However, our order of operations without the brackets is we're taking away 7y and then plus 8. So I just want you to recognize that there are 3 terms. The 3 terms are 3x, negative 7y, and 8. And there is a constant term. The constant term is 8. That is, that it doesn't matter what our pronumerals are. X could be 0 or 1 or 2 or 3, or y could be the same thing. These terms are changing depending on, like, they're changing value depending on what x is or what y are. So they keep changing. However, 8 always stays the same, so we call it a constant term. It always stays the same. It doesn't matter what x and y are. We will still always have a plus 8. We obviously need to know our different wording about how to write expressions in, or how to write kind of questions in algebraic terms. So just say we have some really hard worded problem. Okay, we use algebra to just write down what that problem is just talking about as a simple expression. So just say we want to say the sum of the total number of people when you've got maybe you've got X boys and Y girls. Well, we would say, the sum of X boys and Y girls, well, the sum is plus. So if we ever had a question like that, we'd write that as there is X plus Y. There is X plus Y people. So if there was 5 boys and 4 girls, we would have 5 plus 4, which is 9 people. Okay, so we could look at an expression like that. Or you might want to find the cost. So just say we want to work out the cost of 6 apples at maybe, D. I'll use D for dollars each. Okay, so what we've got is we've got 6 apples, and we're going to times that by D dollars. But in algebra, we would not use 6 times D. We don't write 6 times how much the cost of the apple is. We write this as 6D. Okay, so this means 6 times D. So just say the apple was $1, then it would be 6 times 1, so it would be $6 for the total cost. If the apples were $1.50, then it would be 6 times $1.50, which is $9 as the total cost. So we are looking at expressions like that. So we might get a problem that, let's make it a little bit more complicated. So just say we say the EG3, I should put EG4 now. So just say we want to work out what is a quarter of X, and then add 5. Okay, we want to just work out what is a quarter of X and then add 5. So we just recognize a quarter. Well, we know that's 1 quarter, 1 over 4, and then of is always used as times in maths. So we would write this as equals to a quarter times X. Okay, a quarter of X, and then add 5, and then plus 5. Now, again, we don't use this time symbol because it gets very confusing. You guys would have seen on my board, I do like a straight line for X, and then I do like kind of 2 C shapes for for times, I do 2 C shapes for an X. Some people do an X like this. Okay, and like lots of people do them differently, but how we often would write this algebraically is we'd actually write it as x over 4 for a quarter of x and then plus 5. Okay, you could write it as just 1/4 x without the times there, and you wouldn't lose marks. However, this is how we would normally see that expression. So I'll have a look at 2 worded problems. So Francine earns P dollars per week for her job. She works for 48 weeks each year. Write an expression for the amount that she earns in a fortnight. Okay, so she earns P dollars per week, and therefore in a fortnight it is 2 weeks. So she earns P dollars in the first week and P dollars in the next week. So you could write it as P plus P. However, because we know a fortnight is 2 weeks, I'm just going to write this as for A, it is 2 times P dollars. Okay, and I'm not even going to put this dollars here symbol. I'm just going to say it's 2 times P, which is equal to 2P. Okay, again, you can just write straight to 2P. I'm just showing you that how, as the expanded form, what it is, but 2P is what she'll get. In 1 year, well, she works for 48 weeks of the year. In real life, you work for 48 weeks of the year, but you get also paid for the 52 weeks of the year. But this question would have just been asking for 48p. This question seems to be assuming she only gets paid when she's working. However, that's not true. She would actually get paid 52p, 52 weeks of the year. And C, in 1 year, if her wage is increased by $20 a week after she has already worked for 30 weeks in the year. So let's have a look and see. So for C, how would we work this out? So we have 30 weeks of the year, she's getting P dollars. So we'd write this as 30 weeks that she's getting P dollars. And then she's also working another, well, the difference with 48, she's working 18 more weeks of the year. Okay? And in these other 18 weeks of the year, she's getting $20 more per week. So that means she's saying plus for 18 weeks, she's actually getting her normal P dollars, but plus she's getting $20. Okay, now I've used brackets here, so this is what she's getting. P plus $20, so if P was, say, $100, this is, she's getting $120 for 18 weeks, and she's getting $100 for 30 weeks. So this would be the expression that we would use. However, I wrote a times there. We don't even use that times, so I could rub that out. I'll use my rubber, I rub that out, and this is what our expression would be. 30 times P plus 18 times P plus 20. Okay, so that should have been, this is question 9 from the exercise. And the final question I just wanted to go through is, if you had a connection fee for your mobile phone calls, they seem to be removed now, but we'll see this in lots of things such as call-out fees and whatnot as just a one-off cost at the start. It says a mobile phone call costs 20 cents connection fee. Sometimes that used to be called a flag for. Okay, I could write flag for as well. So it's got a 20-cent flag for and then 50 cents per minute. So I'm just going to say, just straight up for 12, as soon as I read that, because I know algebra, I'm just going to say the cost is equal to 20 cents, okay, $0.20, plus 50 cents per minute, and I'll just use M for minutes. So I could even say where M is in the minutes that you've talked for. Okay, there you go. I should have read this question just here. The total cost, I've just answered the question, find the total cost in dollars for a call lasting T minutes. So I've just done B just there. So I'll move that down. This is B, given that instead of M, we've got T for time. Okay, A, write an expression in cents for T minutes. So instead of me writing it as $0.2, I would say my flag for the cost is 20 cents plus 50 cents per time per minute. And my final question, write an expression for the total cost in dollars of a core lasting T hours. Okay, so I hope that you're not talking on the phone on a mobile phone for a lot of hours, but if you made a phone call for T hours, then the cost is going to equal that 20 cent connection fee, or 20 cent flag for. Now, because it's 50 cents a minute, then I could work out 50 cents per minute, 0.50 cents per minute. If I times that by 60 minutes, that's going to equal to $30 per hour. Okay, so therefore the cost is going to be 20 cents a minute plus $30 per T hours, where it said T is the number of hours. Okay, and then you could always put values in this. We'll talk about substitution later. However, you will have, just say you talk for 2 hours, you'd be paying 20 cents plus 30 times 2, which is $60. So $60.20. If you work for 3 hours, it would be 20 cents plus $90. Okay, I hope that is helpful. And today you'll be looking at exercise 1A, and then also I'll be posting up something for you to do on Maths Online.